Our incredible eyes, windows to wonder. Wow, think about your eyes for a moment. They are truly amazing, aren't they? These incredible organs are like our personal windows to the world around us. They allow us to see the bright sunshine. They help us see the twinkling stars at night. We can see the faces of our friends and family. Our eyes help us explore and understand so much. Without them, the world would be a very different place, a much darker place. They're constantly working from the moment we wake up until we close them to sleep. It's a big job. Our eyes do so much more than just see. They help us learn new things every single day. Imagine trying to read a book or watch a science experiment without them. It would be very tricky. Our eyes help us navigate our surroundings safely. We can see where we are going, avoiding obstacles. They help us connect with others too. We see smiles and expressions, understanding feelings without words. They are essential tools for communication and interaction. Consider this. Your eyes are working hard right now, helping you read these very words. That's pretty neat. In this journey, we're going to take a peek inside the human eye. It's like a super complex but super cool biological machine. We will explore its different parts. We will find out what each part does. It is a fascinating adventure into our own biology. We will learn how these parts work together. This teamwork allows us to see everything from tiny insects to giant mountains. Get ready to be amazed by the science of sight. It's a story of light, lenses, and incredible brain power. Think of your eye like a very advanced digital camera. It has an opening to let light in. It has a lens to focus that light. And it has a sensor at the back to capture the image. But it's even better than a camera. It can adjust to different light levels almost instantly. It can focus on things very close up and then on things very far away. It even cleans itself with tears. Our brains then process these images, allowing us to understand and react to our world. Science is all around us and inside us too. Let's start our tour at the very front of the eye. The first part light encounters is called the cornea. The cornea is a clear, dome-shaped surface. It covers the front of the eye, kind of like a watch glass. It's transparent, so light can pass right through it. But the cornea does more than just protect the eye. It also helps to bend or refract light. This bending is the first step in focusing the light so we can see clearly. It's super important, handling about 2/3 of the eye's total focusing power. Pretty powerful for a tiny, clear layer. Next up, just behind the cornea, we find the iris and the pupil. The iris is the colored part of your eye. It can be blue, green, brown, or hazel. It's a muscle. And what does this muscle do? It controls the size of the pupil. The pupil is the black dot in the center of your iris. It's actually an opening that lets light into the eye. When it's bright, the iris makes the pupil smaller to let less light in. When it's dark, the iris makes the pupil bigger to let more light in, just like the aperture on a camera. Now let's talk about the lens. The lens is located behind the iris and pupil. It's a clear, flexible structure. Its main job is to fine-tune the focus that the cornea started. The lens can change its shape. Tiny muscles around the lens contract or relax. This makes the lens thicker to focus on nearby objects. It makes the lens thinner to focus on distant objects. This amazing ability is called accommodation. It allows us to see things clearly, whether we're reading a tiny instruction manual or looking at a faraway airplane. What an incredible design. The biggest part of the eye is filled with something called the vitreous humor, or you could call it vitreous gel. It's a clear, jelly-like substance. It fills the space between the lens and the back of the eye. This gel helps the eyeball maintain its round shape. Think of it like air in a soccer ball, but much more delicate. It also allows light to pass through it without distortion on its way to the retina at the back. It keeps everything in place and ensures the light has a clear path. Our eyes are so well engineered. Now we reach the very back of the eye, the superstar of image capturing, the retina. The retina is a thin layer of tissue. It lines the back of the inside of the eye near the optic nerve. Think of it as the movie screen in a cinema, or in our camera analogy, it's like the digital sensor or the film. This is where the light that has passed through the cornea, pupil and lens is focused. The retina contains millions of light-sensitive cells. These cells are called photoreceptors. They are ready to turn light into electrical signals. These photoreceptor cells come in two main types, rods and cones. We have a lot more rods than cones, about 120 million rods. Rods are incredibly sensitive to light. They are responsible for our vision in low light conditions, like at dusk or in a dimly lit room. They don't see color very well, which is why it's hard to distinguish colors in the dark. They are also great at detecting motion. So, when you see something move out of the corner of your eye, thank your rods. They are always on alert. Cones, on the other hand, are responsible for our color vision. We have about 6 to 7 million cones. They work best in bright light. There are 3 types of cones, and each type is most sensitive to different wavelengths of light: red, green, or blue. Our brain combines the signals from these 3 types of cones. This allows us to perceive the entire spectrum of colors. Cones are also concentrated in a central area of the retina called the fovea. This area gives us our sharpest, most detailed vision, so when you focus on reading fine print, your cones are hard at work. Once the rods and cones have converted light into electrical signals, what happens next? These signals are sent to the brain through the optic nerve. The optic nerve is like a high-speed data cable. It bundles together millions of nerve fibers from the retina. It transmits all that visual information from the eye to the brain. Interestingly, where the optic nerve leaves the eye, there are no photoreceptors. This creates a blind spot in each eye, but we don't usually notice it because our brain cleverly fills in the missing information using signals from the other eye. Amazing, right? How do we see the world in 3 dimensions? That's where having 2 eyes comes in super handy. This is called stereoscopic vision, or depth perception. Because our eyes are set a little bit apart, each eye sees a slightly different image of the world. Try this. Hold a finger up in front of you, close one eye, then the other. See how your finger seems to shift position relative to the background. Your brain takes these 2 slightly different images. It then combines them, and this difference helps it calculate distances. This allows us to judge how far away objects are. So cool! Our brains are not just passive receivers of information from our eyes. The brain actively interprets and makes sense of the signals it receives. It flips the upside-down image that the lens projects onto the retina. It fills in that blind spot we talked about. It even helps us recognize faces and objects incredibly quickly. Sometimes our brain can be tricked. This is what happens with optical illusions. These illusions show us how our brain uses assumptions and patterns to understand visual information. It's a constant collaboration between eye and brain. Think about all the things you do every day that rely on your vision. Reading your favorite science book, playing sports and catching a ball, driving a car or riding a bike safely, appreciating a beautiful sunset or a piece of art. Even simple things like cooking a meal or recognizing a friend across the street. Our vision plays a fundamental role in our safety, our learning, our enjoyment of life, and our connection with the world. It's a sense we often take for granted, but it's working for us all the time. The human eye, from the protective cornea to the light-sensing retina, is a masterpiece of biological engineering. It's a delicate yet powerful system. It allows us to experience the richness and beauty of the world in vibrant detail and glorious color. The way light is captured, focused, converted into signals, and interpreted by our brain is a truly wondrous process. So, the next time you look around, take a moment to appreciate the incredible gift of sight. It's one of science's most amazing stories, happening right inside your own head. Keep exploring, keep questioning,